Hi everyone, today what we're working on is something called completing the square, right? Completing the square. Completing the square. It's like finding a soulmate. You're going to complete your square. If your heart was a square, right? I mean, you'd be completing it. We're completing our hearts. Okay. So let's talk about what is completing the square. Let's talk about what is a square in math. When we're talking about a perfect square, what is a perfect square in math? And a perfect square in math is a number like 4, 9, 25, oh, missed one, 16, 36, 49, 81, 64, 100, right? These are perfect square numbers because they're made up of one number squared. I forgot one. One is a perfect square number. Like 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. Right? These are perfect square numbers. They don't exist. They don't happen all the time, right? And these are what we call these nice perfect square numbers. Great. So for us, that was like last semester, okay? But now we're dealing with stuff like x plus something. We're dealing with binomials, trinomials. Do we still have perfect square numbers here? And we do. Example, let me give you first is this. If I give you x plus 2 times x plus 2, this could be written as x plus 2 squared. See how that's a square there. That's a perfect square. Now, what happens when I multiply x plus 2 by itself? X times 2 times x plus 2. We go x times x is x squared. X times 2 is 2x. 2 times x is 2x. And 2 times 2 is 4. Okay? So here is a popular mistake that kids do. They say, oh, Mr. Ko, this is just a square. So that's just x squared plus 4. And this is totally wrong. Okay? When people say, oh, when you square, you just square the front, square the back. That's if it was multiplication, right? But there's a plus sign here. And when you do have a plus sign, you end up with x squared plus 4x plus 4. You square the front, you square the back, and you double that middle. This is a double, right? It's not 2x, it's not just 2x, it's doubling it. So we end up with 4x. You square the front, you square the back, and you double the middle. Now, for us to talk about how to complete the square, what if you were missing a part of this square? So in this case, we have a x squared, x, 4x, and 4, okay? So I'm going to give you a situation where what if I give you x squared plus 4x plus 4x plus blank? What would that have to be so that this would be a nice perfect square problem? That this would be a nice perfect square problem. Okay? Well, we just did it up on top. It's if this was 4, we would have a perfect square. And then that means this would have to be 2. How did I come up with all that stuff, Mr. Cho? How'd you do it? Now here is the pattern, okay? The pattern is, didn't we double to become the middle term? If this was a perfect square, this would have to be double the middle. Now, here is the trick. We're gonna go around in this circular pattern. You always divide the middle by 2. 4 divided by 2 is 2. And we square it to bring it back. Let me show you that again. You take the middle. If I did not know, let me erase this. If I did not know what that perfect C value is, we're gonna call this C because it's ax squared plus bx plus c. C is by itself. That's what I call my perfect C. This is my perfect C. Perfect C, right? That's my perfect C because that's my perfect square number. How do I end up with it? Well, here's the pattern. You take the number divided by 2, and then you square it to go back. 2 times 2 is 4. Let me give you another one. So if I give you a list of perfect square numbers, let's go ahead and do that on the side here. You'll see that there's a pattern to it. X plus 2 squared, x plus 3 squared, x plus 4 squared, x plus 5 squared, okay? These become x squared plus 4x plus 4, x squared plus 6x plus 9, x squared plus 8x plus 16, x squared plus 10x plus 25. I was able to do that so quickly because the pattern is built into the problem. Square the front, square the back, double the middle. Try it. Square the front, x times x is x squared. Square the back, 2 times 2 is 4. Double the middle, double 2x is 4x. Let's see if that pattern works for the other problems. Square the front, x times x is x squared. 3 times 3 is 9, x squared and 9. Double the middle, double 3x is 6x. Square the front, square the back, double the middle. X times x is x squared, 4 times 4 is 16, and 4x double is 8x. So these are what we call perfect squares. If I give you a problem that fits this pattern, we can write it as this perfect square version. If I give you x squared plus, let's do 14x plus, what do you think this would be to make this a perfect square? Well, what's half of 14? 7. This would have to be 7. And what's 7 times 7? That gives us 49. So to have something have this nice shape of a perfect square, something that's squared, it's always following the pattern. You square the back, you square the front, and then you double the middle. Square it, and then double the middle. That's how we end up with all our perfect squares. Just like not every number here is a perfect square, not every number in the known universe is a perfect square, only some of them are. Same thing for our factors here. Binomials don't always give you perfect square, but when they do, they always follow this pattern. Square the back, square the middle, and double. So square the front, square the back, and double the middle. Okay, so you'll see some problems, and they'll ask you, hey, what is this perfect C value that would work here? So if I give you x squared plus, let's do, I'm trying to think, 8x, what would be that number in the back? You could look on the right, you could do that. But instead, here's the pattern. Divide by 2, and then squared. Divide by 2, and then square it. 8 divided by 2 is 4. 4 squared is 16. And if that's the case, this is x plus 4 squared, right? Because 4 times 4 is 16. Let's do another one. X squared plus, let's do 10x again. Let's do a negative, actually. So what happens when it's a negative? Negative 10x plus what? Divide the middle by 2. That's negative 5. And square it. What's negative 5 squared? 25. X minus 5. That's how we end up with a negative in the front. So for us to come with perfect squares, it's not that hard, but there is a pattern to come up with it. We always divide the middle by 2, and then we square it. And that's how we're going to find those perfect pieces to make this a perfect square. If I give you x squared plus 8x plus 9, is this a perfect square problem? Is this a perfect square problem? X squared plus 8x plus 9. Well, try it yourself, test it. If I divide the middle by 2, that's going to be 4, and 4 squared, that should be 16. Is that 16? It's not. But you can make it a perfect square problem. Have you guys ever not had enough money to do something? Right? What do? If you really want it? You go borrow money. You ask your mom, you ask your dad, you ask your grandma, hey, grandma, can I borrow some money? Hey, dad, can I borrow your credit card? We find ways of doing it. And that's what we're going to do today. We're going to borrow some money. Great. Okay, so here we go. So this is our pattern for what we're going to do today, is we're going to change. Now, we're going to use completing the square. Okay, so here's today's goal. Use completing the square to change a quadratic to change quadratic form to vertex form. Yesterday, last time we worked together, we were talking about how to graph parabolas. And if the parabola is in this nice form, y is equal to, they call this vertex form. Y is equal to a, x minus h squared plus k. Hopefully you're able to graph those super easily, super fast. But if it was in a quadratic form, of ax squared plus bx plus c, it was in this x squared form, then we weren't able to graph it quickly. It was actually quite difficult. Now, if I could change it to become vertex form, we could graph these super fast and super efficiently. And that's what our goal is today, to change something from quadratic form to vertex form. And we're only going to go do the first two easy levels today. So that's our goal. We're going to use our skills to change something from quadratic form to vertex form. So let's go ahead and go back to the problem that we just had. Y is equal to x squared plus, no, let's give you guys a 6x plus 8. We'll do this one instead. We've done this before. Okay. Now, how can I change this into a nice form like y is equal to something like x plus 3 squared minus 1? How can I get this into its nice vertex form? Because if it's in the vertex form, I can graph this. What's my vertex? My vertex is -3, comma -1. If you remember how to lean that off, -1, 2, 3, -1. And then since the a value is 1, one space over, one space up, we could graph our parabola in a matter of seconds. But I can't graph the thing on the left. So the goal of today's work is to change from this form to this form. And we can do that in literally one line. One line, okay? One line. So work with me here. We're gonna take a couple shortcuts, but it'll be doable. Here we go. So I need to make this into a nice perfect square problem. See, there is no perfect square here, but there's a nice perfect square here. And that's actually why we call it completing the square. I'm gonna make it perfect. Anyone ever put makeup on just to make yourself look a little nicer for pictures? You ever dress up, put on your nice shoes to make yourself just perfect? That's what we're gonna do. We're going to change ourselves so we become this nice perfect square. Now here's the gimmick. This is not in perfect square form at all, but I want it to be. So I'm gonna write what I want. I want this to be this. Now, how do we get there? How do I get from x squared to x plus something? Now, here's the pattern. Take the middle and divide it by 2. That's it. Remember how we're trying to make the perfect square, my perfect c value? This is not my perfect c value. What's my perfect c value? Well, if I write this as x plus 3, now take a look. I want you guys to make sure we're cool here. Isn't x times x, x squared? Okay. And isn't 3x plus 3x, 6x, right? So what was that last one? What's the square the back, square the front, square the back, square the middle, square the back? What should 3 squared be? 3 squared should be 9. Do you have a 9 here? No. So here is my trick. We are going to write this as, everyone please look at the screen. I'm going to write a 9 in the problem. But can I do that in math? Can I just stick in random numbers? Can I just stick numbers in my bank account? Oh, Mr. Go has $1,000 in his bank account. Oh, no. I'm gonna stick a number there. I have $1 million in my bank account. I just added 3 extra zeros just because I wanted to. You can't do that in math, can you? So here's what the ploy is. If I add 9, I'm going to also minus 9 at the same time. Okay, if you borrow $9 from your mom, you have to make sure you pay back. So you're $9 deep. You have $9, but you owe her $9 now. And this is what I'm doing. Let me show you guys algebraically what am I really doing. So please take a look. We have the number plus 8 here. That's how the problem started. Is it wrong for me to add numbers? Well, not if I balance the equation. If I write plus 9 and minus 9, I want you to look here. Isn't x squared plus 6x plus 9? Isn't that a perfect square here? Right? That's this guy here. X squared plus 6x plus 9 is a perfect square. Because 3 times 3 is 9, x times x is x squared, and 3x plus 3x is 6x. That's my perfect square. Now, what do we do with the rest of the numbers? Well, if I used up this or this, don't we have -9 and 8 left over? So we combine the leftovers. We combine whatever we owe. We'll pay back later. -9 plus 8 is -1. And this is what we're going to do. I do not want you to have to rewrite this section. Because do you see how I pushed the numbers over? Instead, please bear with me here. And please watch what I'm going to do instead. Instead, we wrote, let's go back to how we start off the problem, plus 8, right? And I'm going to write plus 9 and minus 9 on top instead. X squared plus 6x plus 9, that is my perfect square. We're going to combine the leftovers. Negative 9 is what I borrowed, plus 8 that I have becomes negative 1. And that's how we end up with our complete the square. We're going to do this 1,000 more times. Well, not 1,000, like 4 or 5 more times, so you guys can catch the rhythm, okay? Let's catch the rhythm. Let's do this again. Y is equal to x squared plus 4x plus 3. Y is equal to x squared minus 6x plus 10. Okay? We have 2 problems here. We're going to complete the square, and we're going to change this to vertex form in one step. Okay, in one line. So I should say one line, not one step, one line. First step I want you guys to do is realize these are level 1 problems. The reason why I call them level 1 is because there's an invisible 1 here. They're easy problems. If there's a 2, 3, 4 negative sign, this problem will be very hard. Okay, this will be not very hard, but it'll be the next level. So first thing you realize, these are easy problems. Just like when we factored, these are level 1 problems. Okay, let's go ahead and try completing the square. If I take this and divide it, what's 4 divided by 2? 2. 2 squared is 4. Nope, that is not right. 6 divided by 2 is 3. 3 squared is not 10. These are not perfect squares. The perfect square would have been x squared plus 4x plus 4. X squared plus 6x plus 9, right? 3 squared is 9. Okay, those are my perfect squares. We don't have that. We have an overweight Asian dude, okay? That's what we got. Got to work out. Let's go ahead and do it. So what we do is we set up what we want. We set up our perfect square. Here we go. Y is equal to, and give ourselves that perfect square. This is the model. This is what we want to end up with. And the way we set it up is we just divide it by 2. I want you guys to take a look here. 4 became 2, and negative 6 became negative 3. You guys all see that? I just divided by 2. Now, what's the perfect square here? What is 2 squared supposed to be? We have x times x is x squared. 2 plus 2 is 4. But 2 times 2 is not 3. It's not 3. What's my perfect square? Can you guys type in the chat? What's my perfect square for my left problem? What number would I use? If you can figure out in the chat, what would I use? What is the perfect square of 2? 2 times 2 is what? 3 times negative 3 is what? Thank you. We end up with a 4. We need a 4. So I'm going to write plus 4. If I add 4, I'm going to minus 4. Okay, write that on top. Please write that on top. I'm not kidding. That's all you have to do. On the right side, okay, on the right side, what's the perfect C value I wish? It's not 10. What's the perfect C value I wish? What's 3 squared? What's negative 3 squared? I need a, thank you. I need a 9, right? Plus 9. If I add 9, you have to remember to balance it out, minus 9. Because if I borrow 9, I need a minus 9. I need 09 now, okay? So you might say, Mr. Ko, but aren't you just writing numbers that whatever you want? Yeah, I am, but I'm also balancing it out. If I take $4 from my piggy bank, I have to remember I am $4 less now. Here we go. Now please watch. X squared plus 4x plus 4, that's my perfect square. That's this guy here. What's left over? Combine this. Negative 4 plus 3 is negative 1. That's completely the square. On the right, x squared minus 6x plus 9, that's my perfect square. That's my perfect square. We combine out what we have left over. Negative 9 plus 10 is positive 1. That's our completed the square. So we're borrowing to complete the square because we need that perfect C value to complete the square. And 3 ain't going to cut it. 10 ain't going to cut it. Okay, let's do this again. Make sure you guys are copying this. If not, this next test will be quite difficult. And if I don't see the work of you guys completing the square, I can't give you credit for even the graphs that you write. So y is equal to x squared plus, let's do 6x minus 2, and y is equal to x minus 10, x squared minus 10x plus 20, okay? Okay, first step is these are level 1 problems. There's no a values in the front. That's just an invisible one. Perfect, easy problem. So we're going to go ahead and ask ourselves, is this a perfect C? 6 divided by 2 is 3. 3 squared is not 9. Okay, 2 isn't 9. 10 divided by 2 is 5. 5 squared is not 20. Let's go ahead and complete the square. We didn't make this. I need to make this guy into a beauty queen. You getting ready for the problem? You gotta get dressed up. I can say, gotta get dressed up. So here we go. Y is equal to our perfect square now. Y is equal to our perfect square. We're completing this, or we're making this complete. Okay, so what do I write inside the parentheses? X plus, always divide the middle by 2. Always divide the middle by 2. That is the rule. Just divide the middle by 2. That's the pattern. Square the front, square the back, double the middle. What's the opposite of double? Half the middle. So what's half of 6? 3. On the right, what number am I going to write here? X minus what? In the chat, if you can write, what's that number? You can private message me. Thank you. Perfect. Got it. Easy, right? That's going to be 5. We always divide the middle by 2. Then we're going to show you guys back up here. Divide the middle by 2. 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 Whenever you complete the square, it's always half that middle value. Perfect. Now, what's a perfect C value I wish? Well, 3 squared, isn't that 9? I need a 9. So I need a 9, but I don't have a 9. Over here, what's a perfect square of 5? 5 squared is plus 25. Ms. Ko, why is it positive when it's negative? What's negative 5 times negative 5? It always becomes positive, so it will be plus minus for us. So we have our perfect square. This is our perfect square here. This is our perfect square. And all the leftovers, flush them down the toilet. So negative 9 minus 2 is negative 11. Negative 25 plus 20 is negative 5. We have just completed the square for both these problems. You might say, Mr. Ko, it doesn't look like it. Are you sure x squared plus 3 squared minus 11 is the original problem here? You're right, it doesn't look like it, but let's go ahead and double check it. If I multiply it out, I'm going to go ahead and check it now for you, okay? For those guys who don't believe, I doubt anyone doesn't believe. But if I believe this, it's x squared plus 6x plus 9. That's my perfect square. Square the front, square the back, double the middle. And what happens when I minus 11? What's 9 minus 11? That's the negative 2 we needed. Okay. So you want to double check it? We are not changing the value. We're just changing the way it looks. We're changing it so it's a form that I can graph easily. Look on the right, x squared minus 10x minus plus 25. If I minus 5, what's 25 minus 5? That's the original 20 that we started off with. So we borrowed the 25, but we paid it back. We covered it by minusing 25 to the problem. And that's how we complete the square. Let's do 2 more of these to see if you guys can if you guys can figure it out. If you guys have figured it out yet. Y is equal to x squared minus 20x, let's say plus 99. And then x squared, y is equal to x squared plus 12x plus 30, okay? Let's look at these 2 problems here. If I ask you to graph these problems, do you really want to graph 99 and graph 30 on the right? This seems like a lot of work. Well, let's find the center. Where would the vertex be? Well, we have to get vertex form. Let's go ahead and change the vertex form. Y is equal to, y is equal to. Now let's set up the problem. Okay. So in the chat on the left, what would this number here be? X minus what? What do you guys think in the chat? Got it. Okay, some of you guys are pretty fast. Yep, that's right. Perfect. It's gonna be 10. Negative 20 divided by 2 is becomes negative 10. So you're gonna just divide it, whatever it is, you keep the sign, just half it. Because that's a pattern. All our perfect squares are this pattern. You take the middle, divide by 2. Okay, what's the perfect C value I wish? What's the value I wish? What's the value I want to write up here? In the chat, can you guys type, what's the value I want to write up here? Oh my gosh, you guys are so fast. So you take it, 10 squared, it's going to be 100. That's right. If I add 100, I'm going to minus 100 because we need to balance out the equation. You can't just come up with $100. We can't be like the US government, right? I mean, I wish I could just print money. And 100, negative 100 plus 99 is going to be 1. That's it. That's where the graph starts. This whole graph, even though it says plus 100, is the vertex, real quick, is going to be 10 comma negative 1. I can tell where the graph starts. Okay, so let's look on the right. What would that be? So what number am I going to write here? What do you guys think in the chat? Perfect. You guys are super fast. Oh my gosh, you guys are so fast at this now. Okay, 6. Perfect. And then what's a perfect C value I wish I had? 6 squared is what perfect C value I wish I had? Got it. You guys are super fast. I wish I had 36, but I don't have 36. Darn it. So if I add 36 and minus 36, and we end up with a negative 6 here. Okay, you guys got it. You guys are way ahead. You guys are super fast with this, right? Like TJ said, he would just think, hey, what number do I need to get from 36 to 30? And you end up with that negative 6. Now, some people get confused as a positive 6 or negative 6. That's why I write it down. So it's obvious. You can see that negative 36 plus 30 I still owe 6. And we're there. Now, how does this problem change when there's a fraction? All my numbers have been even so far. Even, oh, sorry, that's not even. Even. Does this problem change when they're odd? Answer is no. It doesn't change. The pattern is still exactly the same. Now let's try with an even number, oh, an odd number, okay? Y is equal to x squared minus 5x plus 3. Uh-oh, now that's odd. If we still want to complete the square, we still follow the same steps. So y is equal to, can you guys type in the chat, make a guess. What do you think it's going to be if I cut 5 in half? What's half of 5? Well, half of 5 is 2.5, right? That's perfect. 2.5 is great. And I would normally have said 2.5, but let me write this, I'm gonna erase it. If I write 2.5, how many guys can square 2.5 in your head? You can't. What if this was 7? What if this was 11? What if this was some other crazy odd number? So here's our trick. So please follow along. And instead of writing 2.5, write 5 over 2. Write that instead. And the reason why is, I'm going to show you, just remind you, you can square a fraction really easy. So, okay, whenever you have a fraction, just write a 2 on the bottom. You're dividing by 2, just write it as a half. Let's do a problem on the right. Y is equal to x squared plus 7x plus 3, okay? This would be y is equal to x plus, what do you guys think in the chat? Tell me, what am I going to write? I'm not going to write 3.5. What should I write instead? Got it. I'm seeing 7 divided by 2. Great job. 7 divided by 2. I'm going to tell you, you do this, it'll be super easy, okay? Trust me. I guess, trust, yeah. Okay, so we would normally square it now, right? 10 becomes 100. 6 becomes 36. Do you guys know what a square of 5 over 2 squared is? What is 5 over 2 squared? It's 5 times 5 and 2 times 2. It's 25 over 4. The reason why I want you guys to write it as a fraction, good job, is that when you square it, it's just square the top and square the bottom. 5 times 5 is 25, 2 times 2 is 4. If I add 25, I have to minus 25. So TJ, the problem is with these problems when they're fraction, if you try to do it in your head, it's just going to drive you crazy. On the right, what do you think that fraction would be for 7 over 2? I'm going to what? What do you think? 7 over 2 is going to be 7 times 7 is 49 over 4. If I add 49 over 4, I'm going to minus 49 over 4. Please, if you guys see that these aren't super hard, sure, the problem got more difficult because we now have to do the fractions, but it's not impossible. It's just that next level of difficulty. So if I have fractions, fine, just square it. 5 times 5 is 2 times 2 is 25 over 4. Anyone confused right now when I'm writing these 25s and this 49 over 4? Anyone confused about this? How I got these numbers? If you want, you can raise your hand. You can just tell me to rephrase. Okay. Now, here is the next step. Please, if you need help, please let me know. It's how in the world do I combine these two? How do I combine a fraction and a non-fraction? And I'm going to write this a little bigger on the bottom here so you guys can see it once. 3 minus 25 over 4, I can't do it, okay? So here's what I do. I cheat. You guys ever go to an arcade? And when you go to arcade, you trade $1 for a bunch of coins, right? So I'm going to change $3 into quarters. And the way we do that is we multiply it by a fraction, 4 over 4. And remember, this is how we get common denominators. We multiply the top and bottom by the same number to change them into a fraction, to a common denominator. So 4 times 3 is 12. Is 12 over 4 the same as 3? Is 12 over 4 the same as 3? 12 divided by 4 is 3. But now, since they have a common denominator, I can easily combine them. So that's the big idea here. We're going to do that in this small space here. You might say, Mr. Ko, really? That seems like a lot of work. No, here, watch. I'm going to redo all this stuff in this much space here. I'm going to do this in this much space. That's how much space I'm going to need from you. Okay? So please take a look. That's all the space I need. So here we go. I need 3 to talk with 4. So what we do is just write this, write 4 over 4 here. 3 times 4 is plus 12 over 4. And then we can combine these two because they're right next to each other now. Oops. They're right next to each other now. And 25 plus 12, they cancel out to become 13 over 4. That's how much space you need for fractions. Yes, it is a little bit more work, but if you look at what we did before, the only difference is this section here. That's the only new step for fractions. That's the only new step for fractions. Let's do it on the right. Can I combine 49 and over 4 and 3? You can't. What common denominator do we need? We need a common 4. So look here. If you don't like fractions, it's okay. 4 over 4. 3 times 4 is 12 over 4. Isn't 12 over 4 the same as 3? Right? These are the same numbers. I just made change. Now 49, negative 49 plus 12 cancel out to become negative 37 over 4. Okay. Okay, let's just do one more. Y is equal to x squared plus 9x minus, let's say 4. Let's do plus 4, okay? Okay, so I want to make this into a perfect square, so I need a bubble up. Let's bubble up. X plus, just divide the middle by 2. Always just divide by 2. 9 over 2. What's a perfect C I wish I had? I see 9 over 2. That's an ugly C, but it's perfect in my eyes. 9 times 9 is 81. And 2 times 2 is 4. If I add, I need a minus the same number. Now, I can't get this 4 and this 4 to talk because of the fraction. So I'm going to change it by multiplying by 4 over 4 so I can get common denominator. 4 times 4 is 16, so I'm going to add 16 over 4. Please take a look. 4 is really 16, right? Over 4. Same number, I just made change. That's how you get fractions to talk to each other, give them a common denominator. Now let's go ahead and combine these two numbers. Negative 81 plus 16 is, I want to guess 65. Is that right? 60. So minus, I think 65, 70, 80, yeah, 65 over 4. Okay, that's it. Now, this is an ugly number, you're right, because this wasn't a nice center number, which is fine. That's just what it is. Now we have one more problem, okay? And this is what if I have a negative sign? And this next problem is, what if I have a negative sign? And this one is, I would say, it is a level 2 problem now. Whenever you have a number in front, whether it's whether as long as it's not 1, we have this type of problem now. This level 2. So y is equal to negative x squared plus, let's say, 4x, and we'll say plus 5, okay? Now, this is not a level 1 problem anymore because there's a number in front that's not 1. 1 is easy. Factoring with 1 is easy, easy peasy. But because it's negative, here is the steps. We are going to ask the negative to leave. But we're going to factor it, but not only from the front, but also from the middle term. And that is the way I teach it. Some people would factor from all 3, but I will not factor from all 3, just the first 2. Negative, parentheses, x squared, minus 4x. I'm going to give myself some space, plus 5. Okay, please leave yourself some space for these problems. These are what I call level 2 problem, okay? Level 2, fight, level 2. So I'm taking the negative out because there are no perfect squares with negatives in the front. There are no, they don't exist. So I'm going to ask the negative to leave so I can do my thing. Now, if I could cover this up real quick, look, if I just cover that up, isn't x squared minus 4x just a problem that we just did? So here's what we do. We say, fine, the negative is here to stay. So y is equal to negative, and we bubble up now. Okay. Almost done, I got 4 more minutes, so we can do this in 4 minutes. I take out the negative, and now we have x squared again. Hey, x squared, I can bubble up. What would the bubble be? X minus what? What number do we end up with? X minus 2. Right? Isn't that what we've been doing this whole hour? As long as I get rid of the a value, this goes back to a regular problem almost. Now, what's the perfect c value I wish I had? 2 squared is 4. I'm going to add 4. Please pay attention. I'm going to add 4 and minus 4 inside the parentheses. This is all happening in this my little bubble. I don't care about the war outside. I don't care about the drugs outside. I just care about in my little household, we got a nice, peaceful, perfect square going on. Now, here's a weird story. When you guys were kids and you yelled at your parents, Mom, I'm going outside. Don't your parents always yell at something, yell at you to do something? Like, take out the trash. Don't forget to take out the trash. Or, hey, put on a jacket. Or don't forget your socks. Or put on a hat. Put on sunscreen. All this stuff. And this is our rule. If we leave the house, who's waiting for us in front? See how there's a negative waiting for us. So for the negative 4 to talk to the 5, right? It wants to hang out with its friends. But to do that, it has to put on a jacket. And we have to multiply that jacket on. What's negative 1 times negative 4? Positive 5. No, positive 4. Positive 4. And that's the only trick now. In order for me to move numbers from the inside of the parentheses out, we have to multiply it by whatever's in front. We have to distribute it out. So a negative times the negative 4 becomes a positive, and the answer is 9 here. The negative is still multiplying the perfect square. Yeah, see how negative is still there? But because you wanted to leave the house, we had to multiply you. Give you your lunch bag, we'll give you your jacket, you can leave first, we'll catch up to you. And that's it. That's us using a negative. Let's do this one more time. Y is equal to negative x squared minus 6x. Let's do plus 7, okay? All right, I don't like the negative sign in front. Here we go, we're gonna kick out the negative sign. So y is equal to negative x squared plus 6x. Give yourself some space and 7. Give yourself some room, right? My family's gonna grow really quick. I'm gonna give myself some space. Now that we have this nice perfect square ability, the negative's not there messing with us anymore. We can rewrite it as my perfect square now. What would go in that perfect square? X squared plus 6x. How did we do this problem before? It would just be x plus divide by 2, 3. What's a perfect square I wish I had? Remember, this is my little home here. 3 squared is 9. If I add 9, I have to minus 9. We have a perfect square, x squared plus 6x plus 9, that's my perfect square. Almost done. Now, hey, -9 wants to play with his friends outside, right? He has to combine. We've been combining these the whole time. But you have to put on your jacket. Get that jacket on. Put on the jacket. Negative to negative is a positive. 9 plus 16. And that's it. That's what we do with negatives. Now, is this going to change if I have like the number 3, 4, 5, or 6 there? No, it's exactly the same step. We're going to put on a jacket. This time we're going to put a jacket of a 3, 4, 5, or 6, whatever that is. We're going to multiply so we can leave the house, right? That's it.